Do I just leave this here? Pam, 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 Pam. How do I make this work? Okay. Okay. Hello, everyone. My name is Doreen Saskin. Welcome to Holy Blossom, and thank you for joining us for this event in our series of expert talks brought to you by the committee of the Luke Sklar Mental Health Initiative. This initiative was established in 2018 by a group of volunteers whose goal was to provide education, support, and resources related to the challenges of living with or supporting someone with mental illness. Our aim is to contribute to ending the stigma around mental illness and to encourage those who need help to seek it. This talk will be recorded to allow those who are interested to view this at a later date. And we invite our live stream guests to post questions at any time in the chat box. Is getting a good night's sleep one of your priorities? If you're struggling with sleep, you are not alone. Tonight, we are so fortunate to have Dr. Jan Raytav with us as our expert speaker on how to improve your sleep. Before we invite him up, Rabbi Eliezer McCarroll will provide us with a brief Jewish reflection. Thank you.
Good evening, everybody. I always think it's ironic that my initials are REM for someone who doesn't sleep. Okay. So in thinking about this evening and this gathering, I, of course, turned to our Jewish wisdom, and what immediately came to mind, or maybe not immediately, but fairly quickly, was a blessing that we say every night. It is the Hashkivenu blessing, and that word Hashkivenu means to lie down. It is part of the prayers that we say before we go to sleep. And it also, right before it, has the Shema. So when we are saying the Shema in the evening, this Hashkivenu blessing is part of it. And so I'm going to read a little bit. Hashkivenu Adonai Eloheinu l'shalom v'hamidenu malkeinu l'chayim. Grant that we may lie down in peace, Adonai our God, and raise us up, O Sovereign, to life renewed. Spread over us the shelter of your peace, guide us with your good counsel, and for your name's sake be our help. Shield us from hatred and plague, keep us from war and famine and anguish, subdue our inclination to evil. O God, our guardian and helper, our gracious and merciful Sovereign, give us refuge in the shadow of your wings. Guard our coming and our going, that now and always we may have life and peace. Baruch atah Adonai shomer amo Yisrael la'ad. Praised are you, Adonai, whoever guards your people Israel. So from this small prayer, we can learn two very brief things about our relationship to sleep in the Jewish tradition. So one is that sleep was actually seen as a dangerous state because when our sleep is frazzled or compromised, the world seems that little bit scarier. And we know that the world feels scary right now and required divine protection. It was a vulnerable state in which we needed to be protected. However, what we learn from our prayer is that sleep is not just rest for our bodies, it is also rest for our souls. And that is what makes it so crucial. So as we learn from Dr. Raytav, let us hope that we learn what rest is, that we may lie down in peace and wake up again well and truly renewed. It's Erev Tov.
Thank you, Rabbi McCarroll, for always framing things so beautifully for us before our speakers. My name is Pam Hamovich, for those of you who haven't met me, and I am one of the co-chairs of this evening's program. Come on in. The sound is not on? Oh, speak louder. Is that better? Okay. Thank you. Okay, we'll just wait for the people to have a seat. Thank you for joining us tonight. And again, thank you, Rabbi McCarroll, for reminding us how sacred sleep is and how it can rejuvenate our soul. And hopefully tonight we'll all be able to go home just and have a little bit better sleep than we did last night. So now it's my pleasure to welcome Dr. Jan Raytav. Dr. Raytav is a clinical and health psychologist with over 40 years of experience in helping those who experience serious problems with sleep, pain, anxiety, depression, trauma, and chronic health conditions. He has written chapters on the clinical management of sleep and pain problems and contributed to current Canadian guidelines for managing the risk of sleep problems for heart conditions. His book, entitled Putting Trauma to Sleep, underlines the critical role of sleep for both mental and physical health and provides trauma therapists with a step-by-step plan to integrate sleep repair into their clinical work. Please join me in welcoming Dr. Jan Raytav.
Thank you, Pam. Rabbi, thank you all for showing up. I'm so excited to be here. Can you hear me? No. Okay. Get it much closer. Is that better? Okay. I'll try and be as close to the mic as I can. So welcome. I'm excited to be here. One of the things that I am most passionate about in life is sleep. And this goes back to when I was a little boy, and people had trouble with my name. And I kept saying, it's yawn. It's pronounced like in the morning when you wake up and yawn. And I guess that meant that I was destined to go into behavioral sleep medicine. So that's what I've been doing for now 40 years. And I'm excited to share my learning and to give you some tips on what you can do to improve your sleep. At the end, I'm hoping you have questions, things that are on your mind. Maybe I can answer some of those. So as we go through the presentation and things do come up in your questioning mind, you will have a chance to ask about those. So I'm going to begin with a very simple statement that all of you are experts at sleep. All of you. And to prove that, I'm going to show you how we all came into the world. Nobody needed a lesson or how do I do this part right here. We do sleep normally. It's just in the process of living that we kind of mess it up. And that's because life has many dangers. So, in terms of what the flyer that advertised what I'd be talking about listed, so these are some of the things that I'm going to address. This is not meant as an academic lecture. Instead, I want to talk about some of the things we understand about sleep. And as I kind of walk through some of these ideas, maybe you can think about, oh, wait, I'm not doing that. Maybe that's something I can do for myself now that it's kind of more, that I'm more aware of it. So there should be lots of moments at which you might say, okay, I think I'm going to try that as well. So, oops. Okay. No. It did, yeah. No. Oh, I know. Will this work? There we go. So when you look at sleep as a behaviorist, all you see is, you know, the person is looking with their eyes open and then all of a sudden they slump. And that's it. That's really all the difference is. So if you look at sleep from the outside, it's a very boring state, right? To really understand what the mind is doing and how it is reorganizing for you, preparing you for the next day, we really have to look at it from what is happening inside, and in particular, what's happening in the brainstem. So one of the first questions that we suggested was, that will, or can you use willpower to kind of will yourself to sleep? And of course the answer is no, and I'm sure all of you have tried that at some point, right? And found that it does not work. So, what does get us to sleep? So, this is based on lots of medical research, so there are a number of things that will contribute to your getting good sleep. So first is being active all day, doing stuff, moving around, exercising, talking to people, right? That kind of energy that you have, that your batteries are ready to use, all of that is meant to be used across the day. And every cell has a little energy bundle called adenosine triphosphate. And as you do things through the day, the adenosine triphosphate starts to break down. And then at the end of it, you get this adenosine molecule accumulating in the brainstem. And that begins to tell the brain, you know what, that's enough. Time to get sleep. And we feel drowsy, we feel tired. A second thing is food. When we put food into our stomach, a lot of blood goes down to the gut to process and to find the nutrients and to pull them out. And of course, that also brings a little bit of a postprandial nap, right, where you're tired and you just nod. And of course, our dinner usually is around 6, 7, maybe 8 o'clock, well before we're planning to go to sleep. A third really critical factor is the presence of light or darkness. And I'll show you that there's a small area of the brain that's tracking this 24/7 and telling the brain if it's getting to be dark to change the software, change what we're doing because we've got to get ready. Nighttime is coming. Now, back in the day, before we had electricity, internet, phones, everything that intrude into our daily life today, we lived in caves, or maybe a tree house, and at the end of the day, we knew when the end of the day was because the sun went down. And when it went down, the light disappeared, and it got cooler, right? Plus, we had more trouble seeing others and doing things, so we naturally became more sedentary and fell asleep. And then, of course, what we do is we lie down. And when you move from a standing position to a sitting position, the body relaxes. And when you move from a sitting to a lying down position, the body gets you really so much closer to sleep. So now, if you're paying attention to these biological networks that we're all wired with that help us to get to sleep, you will now notice that we've hacked all of them, right? At the end of the day, we turn the lights on, right? And we don't wait for the room to get cooler when the sun goes down. We have central air, and we keep the temperature at a comfortable 20 degrees, day and night. But your poor brain is saying, what the heck? When do I go to sleep, right? So it's losing out some of these innate biological mechanisms. And then maybe worse, we turn the lights off, we lay down on the couch to watch TV, and then laying down and the lights off and everything makes us fall asleep on the couch and not in the bed when we're ready to go to sleep. So those are some of the biological things that we're all wired with that should help us to get to sleep, that we don't always use or use effectively. So if we kind of look at what is it that is making us go to sleep, we have to understand the 3 areas of brain functioning that are present all of the time. And so these 3 areas include your executive or thinking brain. So this is where we form sentences, we create meaning, we communicate meaning with words, other people listen, extract the meaning, maybe ask us a question. So that's the thinking brain. That's at the top level. At the middle level, we have our emotional brain. So all of us throughout the day are experiencing different kinds or waves of feeling. It could be some excitement about getting out of the house. It could be a sense of nervousness. Oh, geez, did I lock the front door? Whatever it is that might pass through the thinking brain, your emotional brain is going to resonate with it as well. It's down below that in the survival brain that sleep is determined or lost. So it's really at that deeper level that we want to begin to pay attention. And so this is a silhouette of the brain. And I'm not going to go into a lot of terminology or background, but the important piece here, and this arrow is pointing to the suprachiasmatic nucleus, which is that area in the center of the brain that is receiving signals from the retina, which is telling that area, is it light? Is it still light? Is it light? Oh, it's turning dark. The sun is going down. And as soon as that area gets the signal that we change formats from being awake and active to being quiet and dormant, it goes to work. And there are two important arms to what it does for us to help us sleep. One of those arms is turning off or inhibiting the arousal brain. Now, our brains are wired to pay attention. They're wired to be alive and attentive and to learn and to do things. And that's really at the very deepest level of the brain. And that's a good thing. That is nobody's problem. Those areas have to be told, hold on, guys, it's dark. It's time to turn off. And so as that inhibitory signal goes down from what's called the VLPO, those areas slowly turn off, and that allows sleep to begin to happen. The other important arm is hormonal. So this is happening in the brainstem, but it's the whole body that needs to know, am I ready for sleep or not? And so that PCN, or the suprachiasmatic nucleus, also tells the paraventricular nucleus, the PVN, to release hormones that tell the body to sleep. And among the hormones that it tells the body to release is melatonin, and it stops sending out stress hormones. So it's a very important area in the brain because it actually can direct traffic down one pathway of being stressed and active, or it can direct it towards slowing down and metabolically getting ready for sleep. And we'll come back to the PVN, so just remember those initials. So here is where the PVN is located in the brain, and when it's happy, and when you're raising your children, you know, hopefully you begin with some kind of a routine around bedtime. So for most people, that includes feeding the child, maybe bathing the child, then having a time when you can play, when the child is interactive and feels seen and heard and valued, and hugged, and then put to bed. And when you do those things with the child feels inside at a deep level that they are loved and appreciated. And their brain releases a magical hormone called oxytocin. Some people call it the love hormone, some people call it the snuggle hormone. It really has to do with being felt and seen. And that hormone turns down an alarm system. The alarm system in the brain is called the locus coeruleus, and it is vital to functioning. And if we look at what the locus coeruleus does, it has two ways of passing on that signal that we're slowing down. Okay, one way that it passes on the signal that we're slowing down is it activates the parasympathetic system. That's the rest and digest, or the brakes. I call it the brakes in the brain. And the other way that it activates sleep is it turns off the gas pedal. And so those two arms are always present. And that's biologically determined because in the world in which we live, in which there are animals that would want to eat us, if we go back to the days when we lived in caves, it was critical that we be able to, on the drop of a hat, press the gas pedal and run to safety. Okay? So this is absolutely an essential way that we're wired from birth. We share this with all mammals. It's not unique to humans. It is the way all creatures that may be food for some other creature can survive at all. So these are very important ways that our nervous system is wired. And that sense that you give your child that they are seen and valued and that they feel it from your hug and your interactions with them can turn off that loud part of the noise in the brain that keeps them, looking for danger or sensing maybe they're not safe. Now, how do we know that those things are happening? Well, when you look at body temperature, so our body temperature is kind of a measure of how much metabolic activity is happening in us. And so what you see here in this graph is a line down the middle, and that line represents when about 20 young adults in undergraduate study, all volunteering to be in a sleep study, and they measured their body temperatures across 24-hour period, leading up to the moment they fell asleep, and then what happened after they fell asleep. And what you can see there is that for about 2, almost 3 hours before they're actually sleeping, their body temperature is dipping. It's going down. And then at that moment that they fall asleep, you can see that the angle of their body temperature drops even further. It's like an assurance that, okay, you're asleep now, you're going to stay asleep. This is good, and we're going to try and keep you in this state of slow metabolic activity. And so in this chart or this diagram is meant to represent, it's not just your body temperature. There are so many hormones that are in sync with whether you're awake and active in the daytime and whether you're sleeping at night. And those things all support your sleep. So in this diagram, you can see the red line, which is that body temperature going down at night and staying down for most of the night. But you also see superimposed on it the green line of cortisol. Cortisol is a stress hormone. Our bodies release it throughout the 24 hours, and it has a circadian rhythm, meaning it's normal for it to go up in the daytime, to stay up for most of the daytime, and by the time that you're getting ready to go to sleep, it's coming down. And that descent, or that lowering of the amount of stress hormone circulating in your body, contributes to body temperature coming down. And then you also see the blue line of melatonin. Melatonin, sometimes called the darkness hormone or sleep hormone, is increasing, which again tries to cement your sleep pattern together. So all of these are trained rhythms. And when you have individuals that have not had a very good sleep-wake rhythm or training to keep to a normal sleep time, okay, these underlying hormonal levels are not in this kind of a nice rhythmic pattern. They can become completely desynchronized, which basically means they're just fluctuating up and down almost randomly, sometimes making you feel sleepy in the middle of a meeting, sometimes making you feel alert when you should be going to sleep, and kind of making it harder for you to actually sleep when you want to. Now, in this slide, this is actual cortisol levels measured in normal sleepers and insomniacs. And one of the things you can see that the normal sleepers are the ones that show that really nice dip, right, that goes down slowly, and then right kind of bottoms out and then starts going up. And just below that, you can see kind of a black line, which represents the nighttime and the sleeping period. And what you see here is that for a healthy sleeper, the cortisol continues to go down, and it's really at its lowest level just before you're going to turn the light off and go to sleep and try to will your body into sleep. So the hormone is actually helping you to get to sleep. Now, just above that, you see insomniacs. And somebody who's had trouble with sleep, maybe for years, okay? The approaching of nighttime and the approaching of the end of the day and the time to go into bed does not necessarily mean for them rest, heavenly rest. It means a battle. It means, oh my gosh, will I fall asleep or not? And that kind of internal turmoil is reflected in that stress hormone. It increases in advance of the nighttime. And of course, it's like pushing what you want the most further away from you, right? And so being able to manage the level of cortisol is an important part of learning to get to sleep when you want to. So I'm just going to pause to kind of list some of the things that if you've been if you've been able to manage to get to sleep and your sleep pattern is more or less regular, and I underline, it does not have to be perfect. All of us, even good sleepers, are going to have bad nights of sleep. It's just simply because our brain is wired to function in a world, and as world introduces maybe dangers or threats or deadlines or other things that we care about, it's going to interfere with sleep. That's okay. Does not have to be perfect. Just has to be good enough. So what are the things that sleep happen, or what does it help you in achieving as you're sleeping? Well, it restores the energy in every cell. So that adenosine that I said that wound down, it begins to rebuild to adenosine diphosphate and adenosine triphosphate. It's like filling up the gas tank in each cell as you sleep. Regeneration. Human growth hormone is released in the first episode of sleep. As you get into deep sleep, your brain releases growth hormone, and that goes out into the body to repair tissues or to build new tissues. So it's like sleep itself triggers a process of maintenance in the body. Detoxification of the brain. So as you go through your day doing things, thinking, planning, organizing, your brain is releasing all kinds of toxic materials that are kind of byproducts of working so hard for you. So these can be misfolded proteins, tau proteins, beta amyloids, all the things that kind of can gum up the brain and its functioning. And all of that is swept out through the night as you're sleeping. Memory. Your brain learns to move memories from your short-term memory up to your long-term memory. And that happens when you're in stage 3 slow wave sleep. Emotional regulation. During rapid eye movement or REM sleep, our brain is activating all the different memory systems in the cortex, figuring out where does this new piece of information fit in with what we already know. And it kind of integrates that into your long-term memory. Emotional regulation. So across the day, many things happen. Some of them take our breath away. Some of them make us feel nervous or scared. Some of them make us feel happy. At nighttime, as you go into REM, all the things that have been tagged with an emotion get preferentially pulled into the memory system. So things that have been boring or dull kind of get forgotten because you want to keep your memory system alive with what you care about or with what you fear. And then finally, you're rebuilding your immune system. So all of that army of immune molecules, white blood cells, cytokines, all of that rebuilds at night as you sleep. And so that is why we want to protect our sleep as much as we can, right? All good things. Now, one of the questions that was asked is, well, what about if you wake up at night? Does that ruin your sleep? No. And let me try to explain what happens. So once you fall asleep and your body temperature drops, and that protects your sleep, your brain goes into a series of shifts in how it operates. And basically, you can see here the brain waves as you go from being awake at the very top to being in a very light non-REM stage 1 sleep, to a middle level of sleep, to a very deep slow wave sleep with delta waves. And you can see how those waves bring the whole hypnogram, which is that bar graph showing you which level of sleep you're in. And you can see it coming down, and then it stays down for quite a while. And after about 90 minutes or so, it shifts into rapid eye movement sleep. And you can see that's a little red spot, maybe 5 or 10 minutes of REM, not long. And then immediately, again, going back into the deep sleep, the slow wave sleep, and usually staying there for 20, 30, 40 minutes, and then back up to rapid eye movement sleep. Now, you can see that these state changes in the brain mean that at any one point, there is risks that, you might overshoot. And every time you go up into rapid eye movement sleep, the brain waves are very much like your brain waves when you're fully awake. And that's why it's sometimes called paradoxical sleep. You're asleep, and yet your brain looks like it's awake and functioning normally. And so when you get into that REM stage, it's so easy to shift into waking up. And most of us will do this many times through the night, and usually we don't even remember those awakenings because they are so brief. But even if they last 5 minutes or 10 minutes, that's okay, because the brain as a whole is still largely in sleep. It's called sleep inertia. Most of the brain areas are sleeping. Yeah, you're awake or you notice the time on the digital clock, but you turn, you get comfortable, and you fall asleep again. So awakening at night is not a big problem. But what is it that makes the brain shift from one stage to another? Well, in this diagram, you see these white bars. The white bars represent something called cyclical alternating patterns. And what it is that the brain begins to talk within itself, so that the thalamus or your midbrain is talking to your cortex, your thinking brain, and your sort of limbic system are integrating, and they're creating waves where they're resonating. It's like a tuning fork, right? So that the area that holds the short-term memory from what you've done in the daytime is replaying that memory, and then the cortex is kind of, let's see if we can emulate exactly what that short-term memory is telling us. And you literally move the file up to your long-term memory when you're getting that synchronization in level 2, level 3 sleep. And there's also some black lines you see at the very bottom, and those represent other waves that are basically telling the brain there is danger. So those are motor and autonomic activity in the brainstem. It's basically waking the brain up. It's saying it's not safe to stay asleep. We're noticing some of the things that are coming up for us are stuff that we want to be awake to see if we have to handle. So if you look at across the whole night, what the brain is doing is it's really serving 3 different functions for you. in the early part of the mind, or the early part of the sleep, the mind is actually not very, it doesn't figure prominently. It's the body that is resting. And the brain is kind of clearing out all the gunk. The lymphatic system is clearing everything out. And that lasts for about 4 to 5 hours, that period of core sleep. So for most of us, we sleep for about 4 to 5 hours, and then we're likely to wake up somewhere around the 4 or 5 hour mark. And from that point on to when we get out of bed in the morning, we're no longer in that kind of a core sleep. The underlying software program is now different, and we're just bouncing back and forth between a fairly light sleep and dreaming sleep, or REM sleep. And so that's the period where some people wake up and they feel they're fully alert, and they look at the time and they say, oh, it's 5 o'clock. I was planning to get up at 7, but this is close enough. I may as well get up. No, please stay in bed. Give your brain a chance to get back into sleep, right? Because that dozy sleep is really important for emotional and memory functions. So these are some of the things that your brain does for you when it's able to kind of get into deep sleep. But what are the things that actually derail the sleep? What is it that makes it hard for us to get to sleep or to stay asleep? So I'm going to talk to you a little bit about these. Remember I called those black bars that were kind of telling you to wake up? So you see on this diagram on the left side, a good sleeper, and how much A1, or the bars that are pushing you to get into a deeper sleep and for the brain to reorganize itself. And then the black bars, which are telling you it's not safe to sleep and you better get up. On the right side, you see the same measures taken from somebody who has had insomnia for a while. And the main difference is, although there's still the white bars, there's still the parts of the brain that are crying out for sleep, saying, please, please, let me sleep. But at the same time, there are other areas in the brain that are saying, no, we're not safe. This is not a good thing to do. And so it's kind of moving the brain into an activated state. And so you have this tug of war going on inside, and the way in which that looks on the hypnogram. So on the bottom, you see that beautiful, wave down into deep sleep, and then back into REM, and then another wave of deep sleep and back to REM. And then up top, what you see instead is the brain does not feel comfortable. It can't really allow itself to go to sleep. And you see that it's almost 2 hours before the person is able to fall asleep. And that, I would guess, is largely cortisol. That's what I was showing you. Their level of cortisol is up high. It's like the brain can't slow down enough. The body temperature can't drop enough, and so sleep doesn't come. And then when it does come, it's not into that really deep period and then up into REM. It's constantly being interfered with. So, what is interfering with it? Well, the interfering nemesis is the alarm system deep in the brain, and it's called the locus coeruleus. And one of the things it does, there's 3 basic ways that it keeps an alarm going. The first is it's activating your thinking brain. Now, I want to be clear about this. This is not thinking as in, how do I solve this problem that I have at work, and I could do this or that. Thinking problems usually involve thinking about alternatives, and then you decide, okay, I'm going to do X. And when you decide you're going to do X, you stop thinking, right? You just go and do X. And that ends the thinking process. This thinking is more like, where is the lion? I just saw a lion. I know the lion's there. It deked behind some bushes. I can't see it, but I know there's a lion. And so that, when you think about it in the context of where we came from in living in caves, and there were lions around, and we'd lose sight of them, that it was actually very functional for the brain to get stuck and to ruminate on where is the lion, kept most of us alive for a period of time. We may have had ancestors that stopped thinking about the lion and instead started smelling the roses, but they were all eaten, so they're kind of out of our gene pool. So that's important. It's activating thinking, but it's not productive thinking. And again, it's biological. This is your brain keeping you out of harm's way. It thinks it's helping you, but it's actually just ruining your sleep. The second arm is the alarm center activates the periaqueductal gray. This is your emotional hub. This is where strong emotions get activated. Things like fear, good emotions as well. So feeling joy, happiness, contentment. And then the third hub is your autonomic activation, your heart, getting your heart rate up, getting your metabolism to go up. And so you can see how this alarm center, if it gets you thinking as you're lying in bed, and it gets you feeling emotions like, oh, I'm so frustrated, I've got to get to sleep, it's 2 o'clock, and you feel your body is still warm, it's not cooling down, okay? You can see that's what you're fighting. It's biology, and it has to be shifted and changed. Okay. Now, what influences that alarm center, the locus coeruleus? Well, if you're out walking and you start to cross the road and a car comes along and almost hits you, okay, we call that an acute stress. Something has happened that has endangered you, and immediately 2 areas in the brain light up and tell the alarm system, danger, right? And so those are the PVN and the amygdala. But if you have stress that lingers, and for most of us in adult life, the stresses that kill us are not being hit by a car, although that does happen, but those stresses that continue and continue in the background, and that they, still kind of haunt us. And there's other areas of the brain that now light up to continue to tell that alarm center to don't give up, don't stop alarming because we're still in danger. And again, this was a very productive way in which we managed to remain safe in dangerous times for a long time. But what it does to your sleep is it interferes with that ability of the emotional system to turn off. So one of the findings more recently is that when you go to bed, when you get into deep sleep, that's the slow wave sleep, you're reactivating memories, things that are important for you from what has happened from the day. And then when you get into rapid eye movement sleep, your amygdala, which is where your alarm, whether you recognize danger, is kind of alive for you. The amygdala is reshaped by your experiences from the day. So if you walked out and then you were jumping back from a car that almost hit you, you're remembering, okay, I know that spot is pretty dangerous, there's a lot of traffic. And it kind of updates your fear system so that you're aware of what you need to do tomorrow. And in this diagram, the upper brain panel is a good, healthy sleeper. And in this experiment, Joos van Someren, a Dutch researcher, probably the person who knows the most about sleep disturbances, or at least researches them, pointed out in the experiment, they introduced an experiment where they manipulated people feeling threatened. They had a karaoke kind of experiment where they listened to their own voices and said, oh my God, is that really me? And, just cringing and feeling awful. And then they were allowed to sleep. And people who were good sleepers kind of replayed that cringing, awful experience. And then in the morning, when they were listening to or asked to listen to the tape again, they were okay. They could listen to it and say, yeah, that's me. It was pretty bad, right? It was really bad. On the other hand, insomniacs, the bottom brains, okay, they also lit up those areas of emotional disgust and whatnot. And then during their sleep, they actually replayed some of it. But on the bottom panel, you can see they felt even worse because it brought back all kinds of other unfinished business. And so in that diagram with the bars, you can see their levels of distress increased after the sleep, whereas the good sleepers actually reduced their level of emotionality. Very important, this idea that sleep is not the same thing for someone who's sleeping well and somebody who's struggling, and that for us to help the person who's struggling to get that system back online is really, really important. One of the most important things that Joos van Someren concluded was that this locus coeruleus, this alarm system deep in the brain, is the root cause of what he called restless REM sleep, resulting in short, fragmented sleep, which prevents emotional adaptation. And we all need to adapt to, and we live in a crazy world with all kinds of emotional challenges. So if we don't have that ability to reset the brain and to kind of change as we go through this, it's much harder. But here's his conclusion. He said, insomnia is not a sleep disorder. Just think about that. Insomnia, not a sleep disorder. It's a disorder of the locus coeruleus hyperarousal, which is basically an autonomic dysregulation. Your survival brain is stuck on something that it's very unhappy with, and we know the survival brain is king. If you're fearing that there's a lion outside your cave, you're not going to get to sleep, nor should you, because if there is a lion there, that would be a very dumb thing to do, right? So I think I'm not going to spend a lot of time on this. I'd really like to hear more, in terms of questions and things like what's on your mind. But the important point here is that this was a study done, and it came out, I think, in the same month that our book came out, about putting trauma to sleep. And the central thesis of our book is that sleep is essential for emotional regulation and that we need to help people sleep better. And also, I've been doing psychology for 40 years along with my partner, Greg. We've shared an office and worked together in the trenches with people with sleep problems and many other things. And I was trained in CBTI, which stands for Cognitive Behavior Therapy for insomnia. It works beautifully for about 70% of the people. And the other 30%, not so much. And the reason is because the behavioral things that you're asking them to do, their brain is not wired to do. They're in a dysregulated state. And you have to get that brain dysregulation to settle down so that it can begin to actually function during sleep. So the important summary, and this was looking at all studies done with adolescents and young adults across a 30-year period where information was collected on REM sleep and on emotional adjustment. And what they concluded is that REM sleep is essential. It's not an additional thing that might be nice for some people. It is essential for maintaining emotional balance, reactivity, and consolidation of emotional information. It's really at the heart of how we regulate our emotional system. And the point they made, same as what I pointed out with Joos's study, during healthy REM sleep, the silencing of the alarm is important. If the alarm does not silence, then it just boots you out of sleep, probably in the middle of a nightmare, right, where you're just feeling overwhelmed and flustered. And again, it's a sign of dysregulation, and again, has to be regulated. So, poor sleep exacerbates emotional dysregulation, and also, for many people, you're at your lowest ebb emotionally at the end of the day. And studies have shown that if you look at positive emotions, negative emotions, that across the day we tend to hold our own. But as we get closer and closer to nighttime, and particularly as we get closer to around 1 or 2 or 3 in the morning, okay, biologically, our emotional systems shift to a very dark place. And if you happen to be up at that time, and you happen to be going through a really rough period, and you don't feel you can reach out to anyone, you can get really, really stuck in that. And that's where a lot of suicidal crises kind of tend to come up. So, bottom line, and I was so happy to read this because having just put out a book on the importance of treating sleep in trauma, they suggested that improving sleep through targeted intervention to significantly improve emotion processing and treatment outcomes in PTSD. That's a critical goal of what we want to be doing for anyone who's experienced trauma. So just to go over some of the ideas in the book, and I think this is not to give you an exhaustive, everything we have or everything we understand about sleep, but just to have you think about this, because I think it's important to understand insomnia is not just one thing, right? There are at least 4 things, which in the book we called enemies of sleep. One important thing is if we haven't yet established for ourselves or for our children a regular circadian rhythm. It is the one thing that you can gift your child that they will thank you for their entire lives if you can. And they will fight you about it because their friends are able to stay up and, scroll till all hours. But trust me, this is something that helps the brain function in a world where they need to function. A nervous system that is stuck on, and that's what trauma and chronic stress does for all of us. Nobody is immune to it. We understand that. I work with people who've had heart attacks, and one of the things that I'm understanding and trying to persuade colleagues is that the heart attack itself is the reason that many medical patients have trauma. They have PTSD. Not because of what they're thinking or early childhood, but because what their heart did almost end their life, put them in a position where the brain, the survival brain, is freaked out. What's going to happen? I'm going to die, right? Physical discomfort, pain, illness, that's also very important, especially as we get older, right? My wife is at home because she's waiting for hip surgery, right? She's in pain, and that's really playing an awful role in terms of her sleep. So, what is it that happens when your body is sending signals up to the brain? Well, there's a deep part of the brain, I call it the early body vigilance hub, which basically activates the PVN that I introduced you to earlier, right? And that's going to get the stress hormones and cortisol and all of that going. So it starts that pattern of crisis or stress response. And then it also sends a signal up to another area of the brain, which is like a body alarm hub. And again, this is biology. This is what our brain will do for us. And working with heart patients, if somebody is having a heart attack and the vagus nerve is telling them, I am dying, I can barely breathe, my chest feels like I have an elephant sitting on it. That center is going to activate the areas that I talked about, the emotional brain, the alarm system, the LC, and the amygdala. And those 3 areas of the brain are going to keep you up at night. and tell you it's not safe, this could happen again. So an important idea here is that these signals that send the alarm up to the brain are not just signals and then they just pass. The survival brain does something very interesting in order to protect us. So it doesn't just feel that sense of an elephant sitting on my chest. It locks it into your memory so that you remember exactly what happened. Now, if we go back in time to when we lived in caves and scurried around for roots and berries, and if we ended up at a watering hole where there was a pack of lions and we realized too late, oh my gosh, lions, and we were lucky enough to scurry away and run to safety, everything that we experienced there, right? The smell of the plants in the area, the sound that all of the animals around that watering hole were making, the sight of the sun through the bushes and trees, even the sight of the lions, and the physical sensation of my running for safety. All of that gets locked into your memory. And you know what? It saved us. Because you might, let's say, go away for 10 years to somewhere else where there was more food, then come back to this area. And then if you were walking towards that same watering hole, hadn't been there for 10 years, your brain would say, I remember these sounds. The smells, the aromas, I know this. And you would not even know why, but your brain would say, turn around, go the other way. And you would. So it did protect us in a world where we had to remember where danger was. If we fast forward to today, part of the work I do with the heart patients is to say, you've got a legacy system that's not been updated in 1,000,000 years. It's working beautifully, but it's telling you that you can have a heart attack again any moment. When you get short of breath, when you have trouble, getting up the stairs, those things can trigger that sense of, oh my gosh, I'm going to have another event. So, and that is a normal brain that has struggled through a nearly life-ending event. So it's doing that to protect you. And luckily, these are things that we can now treat. So that's, I think, the good news story. But in terms of what all of us are facing in the world that we live in, we are in times where there is an incredible amount of danger. And unlike any previous time or generation, it's imported into our living rooms. We turn on that screen and we can see horrible things that we would probably not want to see, right? But it's there, and of course then once we start looking at it, we kind of get attracted. What's going to happen today? So it kind of reinforces itself. Okay. Anyway, the bottom line about the brainstem is that when you've had many and different kinds of stressors, whether they're physical, body stressors, or emotional stressors, that will tend to disrupt your ability to get to sleep. And finally, I want to kind of bring to your attention, this is again part of Joos van Sommeren's work, and what he highlights is the importance of genetics. So genetics actually accounts for about 40% of the variation in adult insomnia. What does that mean? It means that if you struggle with sleep and getting terrible insomnia, there's a good chance that your parents, siblings, your biological DNA also inherited that kind of vulnerability or sensitivity to insomnia. Now, it doesn't mean that it can't be treated. It just means that you've got kind of a biological rut leading you quickly in this direction, where others may not have that to quickly kind of get you into that sort of difficulty with sleep. But he also points out that we know that young people, when you bring them into their sleep lab, that you can see that their REM sleep is already broken up. There's that restless REM period, although they don't have any current symptoms. They're not experiencing panic, anxiety, difficulty with relation, all of those other things. They come in later in life. And so the hyperarousal, the difficulty with sleep, and then if that perpetuates, insomnia is now regarded as a transdiagnostic factor. What does that mean? It means that once you have a disturbed sleep pattern, it easily shifts to clinical depression or panic, generalized anxiety, or PTSD. So if you can treat it before it moves you towards other more complex or more difficult to treat conditions, that's a good thing. Okay, and then one of the things Pam asked me to address is, well, why don't the tips that we see, I try a lot of them, they don't work. I tried the peanut butter one, right, where you have peanut butter, didn't do anything, right? Why don't they work? Well, I think an important idea here is that what is driving the sleep problem? And if you can kind of agree with me that there could be at least 4 different things that are enemies of your sleep, then your job is to find out which of those 4 is relevant to you, or which is the most important of the 4. You may not have all 4, you may only have 2. But if you have 2, and peanut butter works for one, but it doesn't work for the other, and you tried it, it helped with the one, but it didn't change the other problem, and so as a result, that tip that helped your neighbor doesn't help you, you get frustrated. So I'm hoping that, that idea that let's look at what is the underlying cause of the sleep problem, and if we can understand what those 1 or 2 or 3 or all 4 are, and then intervene on all 4, that is bound to have much more success than hoping that the peanut butter cure helps everyone. This is a checklist that I developed. I'm going to give Pam a copy of it, and she'll send it out with the resources that every one of you will get after this presentation. And I also wanted to say we have a website. So Dr. Celeste Thurwell is a psychiatrist and sleep medicine fellow, and myself are the authors of Putting Trauma to Sleep. And we set up a website called www.puttingtraumatosleep.com. And there are 2 sides to the website, and it's the side on the left that's meant for people with problems with insomnia, difficulties with sleep for whatever reason. The right side is meant for therapists that are working with people with sleep problems. So, and one of the things that we're working towards is to put together a program for people with sleep problems, which will be like 3 sessions, like a 3-hour morning treatment session where we talk about some of these many issues and then what you need to do to begin to change what your brain is doing. I think we're going to call it sleep repair, rewiring the brain. So, and that'll be up on our website, I think in about 2 weeks. The other books that I would highly recommend, the best general book about sleep, if you want to learn more and really understand how important it is for you and your health, both physically, emotionally, spiritually, in every way. It kind of grounds us into what our body is experiencing, is Why We Sleep. Matthew Walker, really an astounding book. For those that are more interested in how sleep impacts depression, Rosalind Cartwright's book, The 24-Hour Mind, is a masterpiece. She spent over 3 decades examining how sleep leads to depression. Really, really wonderful. And then there's, of course, our book, which is looking at trauma and sleep, which very interesting. The reason that we decided to write our book, we looked at all of the trauma treatment guidelines in the world, and there's a few in the US, Canadian, Australian, British. Do you know that not one of the trauma treatment guidelines even mentions sleep? It's not there. Every person I see who has had trauma has either insomnia, nightmares, or apnea, or other sleep terrors, all kinds of difficulty with sleep, and yet it's not mentioned. So we thought, that's just plain wrong, right? So that's why we wrote the book. Yeah. So that's what I prepared, and hopefully it gave you an idea of what we're dealing with when we deal with sleep.
Don't go anywhere, because I'm sure that our guests and those online also have a number of questions. But before we get to the questions, which I know people are very anxious to, first of all, you've given us so much to sleep on. You've given us so much to think about. And first of all, we want to thank you for being here. And I'll come back to you in a few minutes, but to thank you even more. But we want to give everybody now a chance to ask some questions. Try to keep them a little bit more general so that everybody can benefit from them. And Dr. Raytev will have about 15 minutes to answer some questions. Yes.
I'm going to go to that one slide that you said there are some 4 things you can think about, and then there was a page that we'll get that had hundreds of ideas.
Yeah.
Can you elaborate a little bit about those 4?
Okay, sure. Let me see if I can just go back to that. It was right near the end, right? This one?
Before that one.
Yeah. So this one was saying that the next slide has some suggestions. So, yeah. So each of these 4 are what I call the 4 enemies of sleep, right? So at the bottom, what is it? The bottom left, the circadian rhythm disruption. This is for people that haven't really had a regular rhythm for going to sleep and waking up. And so if you kind of read some of those, you're going to check off, oh yeah, no, that one, yeah, never had a consistent sleeping or sleep-wake routine growing up. Yeah, that applies to me. And as you go through, you're going to have a certain number of check marks in each of these clusters. So if you end up with, say, 6 check marks under circadian, and then 1 under sleep apnea, and 2 under autonomic dysregulation, and then you have, let's say, 5 under body dysregulation, it means that you've got some kind of medical issues. You also have to get a regular sleep-wake rhythm, and CBTI is going to be great for getting that done. And then you also have to get the medical stuff cleared up, because until it's lingering and you're still in pain or whatever it is, that will continue to bother your sleep. So it's just a way of trying to help you figure out what direction do I go in to get my sleep issues sorted out. Yes, other questions, and I'll try to repeat them for the people online. So I saw 3 hands. Oh, there's a microphone. Yes.
You talked about the routine that you typically follow with a child. If you counseled an adult, what would you lay out as a very good way of maximizing your chance of sleeping? What routine should an adult follow?
Okay, beautiful. I would say, in this case, follow the children. Do what children do. I mean, in the sense that what you're providing for the child is a holding environment, right? So having a meal at a regular time, I think adults can definitely be doing that. And then after that, with children, we bathe them, we play, we interact, right? We make them feel seen and felt and that they're important. So that might mean for an adult to call a friend, to maybe have a Zoom call with a family member, even if they're not in the same city or even the same country, we can now do that. And that might give the person a sense of connecting with others. There's other things that you can do, like taking a hot bath. I mean, just that sense of being in warm water. For me, an Epsom salt bath is my nirvana. At least twice a week, I love to soak in an Epsom salt bath. And most of what's in Epsom salt is magnesium. And magnesium helps calm the muscles and relax the nervous system. So you can do that as a included in your routine on some nights. If you have a hobby, something that interests you, if you draw, if you sew, if you stitch, any of those kinds of things, to kind of make sure that you take time for what inspires you, what you care about. I think if you can do that, and then try to get to sleep at the same time. So those are the things that I would say. The one added thing that I think for many adults is turning off the mind. And so one of the things that happens, when you've had a busy day, you go to bed, you turn the lights off and you lie down. All of a sudden your mind goes, aha, I've got you now. And all the things that you forgot to think about or do come streaming back, right? Because there's nothing else to distract you, right? So for those, I suggest they take time earlier in the night to actually write down what are the different things they're going to think about when they turn the light out, okay? And then there's some specific instructions to kind of let go of that. And then when you do go to bed and you turn off the light and you start thinking about that, you can say, I took care of that. That's been dealt with. I can just, relax and wait for sleep. Thanks for the question.
Thank you, first of all, for tonight. We all know about not using screens at night before bed, I think. What about in the morning? I know that a lot of us are waking up and at 6 a.m. doing Wordle and connections and all those kind of things. And I've been reading lately that is not good for you either in the morning, that it sets your day off incorrectly. I wonder what you think about that.
Okay. Well, one of the things that I'm really, really strong about is the transitions. The transitions from wakefulness into sleep at night and in the morning, transitioning from sleep into your daytime. They're both important, and they both have slightly different challenges. I think for the morning awakening, the challenge is that what wakes most of us up is in the background, our stress hormones, adrenaline and cortisol, have been slowly creeping up, right? And in terms of the 24-hour time window, they are at their highest level when we wake up. And so I know for the people that I see who've had heart attacks, most heart attacks will happen between 6 a.m. and noon because that level of autonomic activity is at a peak. What can you do? I would suggest some kind of a morning routine. So meditators are very strong on, as you get up, see if you can get into a nice meditative state, to kind of slow down the brain and the body just a little bit. You might do some stretching. I think the Indian culture has sun salutations, like yoga for the morning. And explore some of these ideas and try them out and see which ones really work for you. Wordle, and I have friends that do that, and they have contests, and I've got it, right? They send texts, okay, I've got the answer in 4 tries. So it's a competitive thing. That's activating the stress system, not making you feel calm and loved and happy to be alive, right? So play it by ear, whatever it is that you think helps you transition into your morning. One of the things that I did for years that I found really helpful is just to sit down with a blank piece of paper and just think about what are all the things I could do today, and things for me, and what are the things I could do for my wife, my son, for my patients, for my friends, etc. And so you end up with a list. And I just choose one thing that I'm going to do for myself today and one thing I'm going to do for someone else today. And I circle those two things. That's it. All the other things don't count. I just want to make sure I do those two things. So that's another way of kind of anchoring yourself in who you are and what you care about, and not get swept up in the competitiveness of the world and all the rest of what we basically drive ourselves crazy doing. So, thank you.
For somebody who does shift work, which is, I'm sure you've treated many of those, and often by the end of the week they're sleep deprived, is there a truth to the notion that you can catch up on your sleep by sleeping extra long on the weekends, let's say?
Good question. So shift work is, I think, a growing thing, right? When I compare it with when I grew up, I remember it was, you weren't allowed to open a business on Sunday, right? And there were big fights about that. So everything has gone to the 24/7, and many, many people are working shifts. My model of how to function with shifts is my mom. So my mom was a registered nurse. She lived to 98, so shift work did not kill her, but she absolutely figured out what worked for her. And what she did is on nights that she worked the night shift, she'd come home and she'd sleep for 4 hours, so usually from 8 till noon. And then towards the end of the day, she would try and lay down and get an hour or two of sleep, if she could. But it was important just to lay down and relax, and then to go into sleep or to go into work for the night. And then, but having those two blocks of sleep, which are pretty close to the nighttime, they're a little bit separated out, but when you finish the night shifts, you can kind of bring them back together again with a little bit of luck. Now, we do know that there are many people whose bodies just don't adjust to shift work. They just don't. And with some of those, if they come to see me, I tell them, this is not the job for you. You can't do this. You're going to pay a price for it. So it's not an answer for everyone, but I do think if you can kind of do that, that would be ideal. The idea that we do have sleep debt, right? And that can happen because we have a period of time where we're working to deadlines and we're scrambling. We all do that these days. And yeah, it does help to get a longer sleep. I would say the most that you want to stay in bed is like 9 hours. Because the brain is really good at using that 9 hours very, very well, and you don't need to do it the next night. In fact, if you have 2 nights or more in a row that you're sleeping in, now your brain is saying, oh, we have a new pattern. We don't really wake up at 7 to go to work. We really sleep into 9:30. And then Monday morning is a disaster because you never got to sleep Sunday night. Yeah. So, yeah. Thank you.
So from what you've said, sleep problems aren't just sleep disorders, they're nervous system regulation problems. So what talk therapy specifically targets this?
Oh, that's a really good question. And I can tell you, as a card-carrying talk therapy person, none. They don't touch the brainstem. And what I write about in the book is about the journey of 30 years of doing this work, that I've only, in the last while, come upon the work of a brilliant psychiatrist, Frank Corrigan, who has learned to understand that when you're working with a person and they're talking about their experience of a trauma, that you can track, you can figure out which parts of the brain are being activated. And what you're trying to do is to allow the person to go back to that very starting point that's activating the traumatic reaction. And so that means for most people, before their emotions kick in. So the emotional system is not the first response system. Before the emotional responses kick in, you have the brain stem, and that locus coeruleus that I was highlighting is the center of the shock alarm system. And it actually is telling the body, oh my God, we're going to die, do something now. And it activates shock reactions like tension in the chest, like tightness into the shoulders, like clenching of the jaw. All of these things are physical, and they happen before the emotional cascade. And if you can clear up enough of the shock reactions from the brainstem, then first of all, the emotions, when they do come in, are much more easily tolerated. Because one of the more difficult things we have to deal with in trauma is when people go back to their experiences, they are flooded, they're overwhelmed, and they can't function, and that's not therapy. So we need them to be able to grow from the work they're doing, and that means to be kind of in control of what their body and mind is doing. And so what Frank Corrigan has provided us is a way of starting at the very beginning moment where we realize, oh shoot, Houston, we have a problem. And the body begins to react, and slowing down those reactions. And it's an experiential treatment. It's not a talk therapy.
A lot of people are taking melatonin to help them, I guess, get into that dip. What's your thought about that?
Oh, good question. Melatonin. When you're young, your body produces an incredible amount of melatonin and it releases it when it's dark. When you get to be our age, it produces a little dribble. There's a little bit of it. It's basically not a sleeping pill. It is a messenger, and it's telling the whole body to kind of slow down, do your best to slow down in terms of metabolic activity so that you can get to sleep. Now, among the people that I work with heart patients, many of them are put on beta blockers. Beta blockers are meant to help with stabilizing the autonomic system, but they have an interesting side effect of interrupting sleep and also generating kind of very vivid dreams. Not nightmares, but just weird dreams that can be pretty scary or off-putting. For those people, I recommend that they do take melatonin along with their beta blocker, and it does seem to help the system be in balance and to not react so strongly to the beta blockers. For others our age, I take melatonin every night. I take magnesium every night, and I think it helps, but I have no actual proof that it helps. But it does make me feel safer, so I keep doing it. But I know that melatonin has many properties beyond just telling the metabolic activity to slow down, which it helps to regulate oxidative stress and other things that might keep the body wired. So.
One more quick one. Any thoughts about naps during the day?
Oh, naps. Good question. Yes, absolutely. So in North America, I think naps are probably a dirty word, right? If you take a nap, somehow you're not strong enough to get through the whole day. In Europe, there's a culture of siestas, and in Europe they've done a study again, with people who are kind of more our age, to see what are the risks in terms of heart conditions. And what they found, very interestingly, is when they look at their whole cohort of people, they had people that never took naps, people that always took naps, and people who sometimes would take naps. And they found that the people who had the most cardioprotective, meaning fewest cardiac visits, events, heart attacks, any of those things, were the people who napped all the time. So, again, I'm all for napping. There used to be, back, I think it was in the 90s, the power nap. I don't know if you guys remember that, where you kind of put your head down on the table for 10 minutes and try and zone out. It's bound to come back in. All these things come back. But I think naps are perfectly fine, for sure.
What are your thoughts about going to bed, sleeping, or thinking that you were sleeping and getting up in the morning and you're still tired? Is there a rule that you sleep,
Yeah.
you wake up, you're supposed to be energized, but you're
Yeah.
not?
I know. So there's a word for that. It's called non-restorative sleep, meaning you're in bed, you're asleep for that whole time, maybe 8 or even 9 hours, but you wake up and you still don't feel rested, right? So that's not a problem of the amount of sleep, it's more of the quality of your sleep. That if you went into a sleep study or sleep lab and they monitored what your brain was doing, that you're probably not getting too much of the non-REM stage 3, and you're probably not getting very much of the rapid eye movement sleep. And when you go for a sleep study, they'll also try and tell you why. So if you're not getting good quality of sleep, it could be because of breathing difficulties like apnea, but it could also be because of stress issues. So in sleep studies, those are called spontaneous awakenings, meaning that your brain just wakes up, nothing caused it, right? There was nothing just before that woke you up. And by waking up, I don't mean that you open your eyes and look around, but that your brain gets out of the deeper sleep and into a very light, non-restorative sleep pattern. So I would say it's just as important as somebody who can't sleep and should probably be investigated, because at our age, as we get older, there's all kinds of things that can go wrong, and in a sleep study, they can at least see if there's something that they can tell you and advise you that will help you. So, yeah.
So I think a lot of the studies that are being done are regarding individuals. Have there been any that have looked at, let's say, individuals who sleep together in terms of sleeping independently as opposed to co-sleeping with somebody else?
Yeah, no, there is many more studies about co-sleeping, and it's absolutely true that connection and skin-to-skin contact and having somebody beside you helps regulate your nervous system more than many other things, certainly more than medicines ever do. And so I think as we kind of get more literature on the topic, I think it will become clear that maybe some of the things we used to do as families, kind of living together and people sharing bedrooms and 2 or 3 or 4 kids in a room, wasn't really as crazy or as bad as maybe we think these days. That no, that's everybody has their own bedroom and that's just the way it's best. I don't know if that's true. So, but there's a lot of literature, a lot of research on it. I'm not up to date on it, so I can't say much more than that. Okay, I think we made it to 9 o'clock. You are right on time.
I think that,
wow.
If given the permission by the temple, we could go on, but we do have to close the building. And there are apparently many more questions that have come in, but we only have so much time. So that's a wonderful reflection on you, and we thank you for that. So just to continue along with the thank yous, as an expression of our gratitude, Jan, I'm going to call you Jan since I've known you for so long, and it is a great name and it is perfect for what you do. We have made the Luke Sklar Mental Health Initiative has made a donation to the Canadian Sleep Society in your honor. As well, the Temple Library, we have a dedicated space for mental health topics under the Luke Sklar Mental Health banner, and your book, Putting Trauma to Sleep, has been purchased, and we have put in a dedication to you to thank you for all of your hard work and for this evening. This book will be added to our collection of resources from past events and is available at Caversham Bookstore and on Amazon or okay. I'd also just want to thank my co-chairs Tabitha Grove and Doreen Saskin for all of the work we've done over the last few months, along with Jan. And I'd like to thank David Rosenberg, Rabbi McCarroll, Deanna Levy, Lindsay Mockler, and Justin Tobe, and Joe Friedberg, especially with all the administrative changes over the last couple of weeks, for all the media, the communications, the admin, and the tech help. And thanks also to our committee, bakers. We're going to ask you to help yourself in just one more minute. We are going to send you some resources and a survey in the next few days. Please be sure to fill out the survey. We like to build our programs based on things that you want to hear us talk about, as well as some of the resources that Dr. Ratav was chatting about tonight. And finally, we hope that you will tell your family members about the next program that we're running, which is on Sunday, April the 26th, between 10:30 and 12, called Mental Health Challenges for New and Expecting Parents: How to Stay Connected After Baby, with our guest speaker, Eliza Shupak. Should be a wonderful hour and a half, and we know that this is not an easy time for many new parents, so we hope that you'll spread the word. And finally, we want to thank all of you for joining us here, and those of you who have joined us on Zoom. Help yourself to some refreshments, stay for a while to chat, and thank you again, and I hope you all have a good night's sleep. Thank you again, Jan. Okay.